Hello and welcome to today's webinar where we're going to be discussing solar energy and battery solutions for large commercial installations and logistics customers. My name's David Porter, I'm a technical advisor for our solar energy team.
And I'm Mitchell and I'm our digital solutions specialist for Perfect Charging. I'll be looking at the Charging Connect platform. We'll take a little bit sort of in depth of the features and the hardware. We'll take a look at the requirements briefly. We'll have a few examples and then I'll go into a bit more depth on the PV Connect side and we'll do a live demonstration from one of our customers on Charging Connect.
Great. Well, first of all, we'll have a look at solar energy and how that can benefit your end customers and then move on to those charging solutions. So Fronius have been operating since 1945 and we have three main business units which are welding technology, perfect charging and solar energy. And we've been working in solar energy since 1992, so we're one of the most long established solar inverter manufacturers. We're committed to European design and manufacturing and our focus is providing solar energy which can be used not just at the point of generation, but throughout the day using battery storage technology. In the UK, we're committed long-term to supporting local businesses and having an established base here in Milton Keynes. We fully own this subsidiary and we have our tech support, our training centre and spare parts all held in the one location. So how can solar support you as a business owner, as a commercial customer? Well, there are a number of key benefits with solar energy. In the past, people were purchasing solar to make the best benefit from their feed-in tariff payments. This was a payment made to you from your electricity supplier for the energy you generated, whether you use that within the property or whether the energy was exported back to the grid. And there were significant payments available, maybe 50 pence or more per kilowatt hour of energy generated. That is no longer available for new installations, but continues to be available for existing PV systems. For new installations, the real focus is self-consumed energy. This is where you take your freely generated energy from your solar panels and you use that to feed the loads within your property. It means that you're offsetting your grid energy costs by not actually importing the energy from the grid. Another benefit is where you have surplus energy, where you're generating more energy than you can use on site. And this is where you can export the energy back to the grid using the smart export guarantee. Energy suppliers will pay you for that surplus energy, maybe around 15 pence per kilowatt hour. And also we have time-dependent pricing. So overnight you may have cheaper electricity rate than during peak times during the day. And of course these will vary depending upon your contract, but it may be possible that you can charge devices up at cheap rates, sell electricity at expensive times, and also store energy when it makes most sense. And there's also peak shaving. This is where we're reducing the maximum demand on your system by offsetting some, if not all, of your energy needs. This may be by reducing the load through your charging solutions, maybe using solar or a battery to reduce those peaks. And as well as those financial benefits, we also have some marketing and PR benefits. You're showing that you're a sustainable company focused on improving your CO2 levels. And also it helps with reporting, so CO2 reports and also billing. So it's not just the financial, but also those marketing benefits as well. So let's just have a look at an example system. And this is looking at the energy consumption during a day. And you can see in this installation, we have a high demand overnight from spotlights, security lights on site. And as the sun rises in the morning, the lights switch off and the solar starts to generate. And you can see the yellow is the generated energy peaking around lunchtime when the sun is in the optimum position. Now let's have a look at that same graph, but we remove the solar energy. And in that middle picture that you can see, we can see that during the peak hours, there's almost no energy being drawn in from the grid. As a result, you have a significant cost saving on your electricity bills. And through our solar web monitoring platform, you can actually calculate how much energy has been saved, how much energy how much money has been made by selling energy back to the grid, and also you can calculate your CO2 savings as well. So some real benefits there. So let's have a look at some of the technology that's involved in the PV system. There's a number of core components involved. Of course, everyone's familiar with PV modules or panels, which are installed on the rooftop or maybe on a ground mount installation. There's of course a mounting kit to fix those panels securely in position. And then we have our solar inverter, which is converting from DC power from the panels through to AC that can be used within your property. We have the various cables, connectors and isolators which link everything together. We have our meters for monitoring how much energy is imported and exported, and also the generation from the inverter. And we have our monitoring system for measuring how much energy is generated, for making sure that the system is performing well. And of course, we also have our energy management solutions, such as our battery, our EV chargers, hot water solutions. But let's focus on what a solar inverter is. As I mentioned, the key thing is it converts DC energy into usable AC. As well as that, it protects the grid from any faults in your PV system, and it also protects the PV system from any faults with the grid. Importantly, if there is a grid failure, the inverter will shut down so that the system is not generating and not sending energy back to the grid, where it may cause an electric shock and injure somebody working on the site. Importantly, the system also provides the information for your PV array. So with the generation, the yield, and any error messages, they normally come via the inverter monitoring system. And importantly now, the inverter is responsible for controlling and distributing energy on site. So whether that's limiting exported energy going back to the grid or switching on the various different loads that you have on site. And at Fronius, we have different inverters for different customers. So we have our tried and tested snap inverter range, which are single phase devices for small residential installations, through to our eco range of larger, low cost, high quality inverters. We then have our Gen 24 devices, which are designed to couple with a hybrid battery solution. We have our Verto, which is designed for medium scale commercial installations for where you have restricted or difficult roof designs where you need flexibility with your array. And then we have our Toro inverters, which are our largest devices, like the one we have here in the classroom. And this is designed for the large-scale installations where maybe we have a large rooftop for a distribution centre. They're ideal because they offer a low-cost, high-power solution for you. Coupled to those inverters, we recommend installing our Fronius smart meter. And the benefit of the smart meter is it's monitoring that imported and exported energy, and it's also controlling those export limitation devices and self-consumption devices like the EV chargers. We can have one smart meter in the main feed-in position, so that's measuring the energy imported and exported from the grid, but we can also use multiple devices to measure other loads on site. We can use a Fronius smart meter to measure the generation of another manufacturer's solar inverters, maybe a wind turbine as well, or to measure individual loads. So if there is a piece of plant in your site that you're really concerned about the energy consumption from, use a Fronius smart meter to monitor that within our monitoring platform. And you can see the live data being produced. You can see by clicking on the yellow bubble, you'll be able to see the current power being generated by your solar or any other generators on site. And if you click on the blue bubble, it shows you all of those loads that are also metered. So you can build up a really comprehensive understanding of the energy usage on site. And this monitoring is through our SolarWeb platform. And SolarWeb is freely available for any users. You simply log on to solarweb.com and you're able to view the energy within your PV system. So you're able to see that live energy data, but also archive data going back since the installation was commissioned. As well as this, we can look at those financial data, and with the premium version we can go into more detail looking at more channels of data and also offer simulation of what would happen if you add a battery or a hot water energy diverter. And of course, those energy management solutions are a really important part of your PV system, whether it's a residential or a larger scale commercial installation. One of the key things we can do is to control various different devices using energy management relays. These are very simple relays which are controlled by a 12-volt signal from the inverter, and we can switch on pretty much any load that will accept a relay-based switching. We simply tell the system at what threshold to turn on. For example, if there's 1,000 watts of energy being fed into the grid, we can turn on a load, and then when we start to see energy consumed from the grid, switch that device off. We can set a minimum time for the system to be on, and we can also set a maximum amount of time per day. For example, if you have a pump that needs to run for an hour, you don't need it to be running all day long. 60 minutes will be long enough. And also you can have a situation where a grey, miserable day, there is not enough energy on site. We can force the system to operate a load for a set period of time at a set time of day. And this is a really simple solution built into every inverter. For commercial customers, you may also be very interested to learn about the Fronius Watt Pilot. This is our latest EV charging solution, the Watt Pilot Flex, and this is designed to integrate again with solar energy and also the other energy management solutions you may have in a property. The idea is to maximize self-consumption by increasing and decreasing the power at which you're charging vehicles. We can have multiple units connected on site and use load balancing to increase and decrease the power going to each of those sites. It's also designed specifically to work with solar so that you can see from the display screen in yellow the amount of energy coming from solar, green for any energy coming from a storage battery, and white for energy that's coming from the grid. You have the option of RFID security chips that you can give to members of staff or to customers to enable charging sessions. And of course there is the numerical display as well, so you can see the power and also the charging that's possible. So there we go, we've given you a brief overview of the Fronius technical solar solutions. Hopefully they'll be useful to you.
So let's take a closer look at how we can integrate solar and charging solutions with MHE. So what is Charging Connect? It's an online portal that allows remote management of a fleet of Fronius battery chargers. There are a large number of benefits to this, such as helping operators to increase the efficiency of their fleet, reducing the overall energy consumption, and especially for operational and environmental impact managers who are able to then get a better understanding of the requirements and utilize their equipment more effectively. Charging Connect can be connected to the internet via Wi-Fi, Ethernet cable, or with a 4G, 5G router, and we've had success with all of these options. It can use a static or dynamic IP depending on the customer's security requirements and preference, and it employs security by design features to ensure that it's always secure and it doesn't inhibit the customer's network security in any way. So just one example before we continue. This is from a customer that my colleague and I went to several months ago, where we installed around 40 Charging Connect gateways, and those are all live on our system, and that's what we'll take a look at later on. And you can see the small black and white device attached to the Unistrut there is what is connecting to the internet. So Tag ID and Battery Connect. Battery Connect is the software which is complemented by the hardware Tag ID, and it's what connects the two together. Battery Connect enables the collection and visualization of battery data in Charging Connect to a much greater degree, and it gives an overview of the battery pool and particularly of the condition of the batteries. So the data is acquired automatically through the Tag ID, but without the Tag ID, the battery data can be entered manually and you will still get a limited amount of information and analytics from that. So the Tag ID itself is mounted inside the battery area of the MHE equipment. There's an electrolyte sensor is drilled into one of the cells of the battery, and then a temperature sensor is placed within the middle of all of the cells, and this is what allows us to gather the accurate information. So what's required for it? Selectiva 4.0 is the easiest option. However, if the customer does have Selectiva 2.0, they can use a P-Control upgrade kit in order to bring it up to the correct spec. So load balancing is again an additional feature that can be added into Charge and Connect. It enables the smoothing of peak energy loads caused by the charging infrastructure. It also allows the charging schedules and timeframes to be set for a specific charger, a location, or a station within different levels of the hierarchy. And the system then intelligently achieves stretching and staggering of the charges without compromising the selected availability of the equipment. And there also includes buffer batteries for unplanned withdrawals, and they are prioritized to make them available with this feature. And here you can see an example of it. If the customer has 9 chargers, you can see that we've enabled 3 buffer batteries within that 12-hour period. Other than that, the charges will be stretched and staggered as far as possible to use the smallest amount of current, which is most gentle for the batteries, and also to use the lowest amount of energy overall. And then it's also possible to have delayed charges where potentially the battery needs to be available, or maybe they have reduced rates at nighttime, for example. So we'll take a quick look at an example from a customer who is a timber merchant in Germany. And you can see here that a station with 7 Selectiva 16 kilowatts saw a 33% reduction in their overall kilowatt output. And so you can see this is quite a significant reduction. So we'll take a quick look at PV Connect on here before we look at it on the live system. You can see that you have an overall AC power consumption. You have the total energy consumed in the blue there. You have the PV coverage in yellow, a timeline across the bottom, and you can see that at the bottom there are some switches which can be turned on or off for the individual bits of information, and the time period can always be adjusted as well. So just to summarize before we take a look on the live system, Charge and Connect is the hub that links everything together. The hardware that is required specifically for that is the gateway, and that is what connects it to the internet. And then as additional features to that, we have the Tag ID, which gives you greater control over the health and condition of the batteries, and that complements the Battery Connect software. On the other side, we then have the PV system with the Fronius data manager and the smart meter that David's already spoken about, and that goes with the PV Connect system and SolarWeb. Load balancing is the additional software feature that ties them all together, and it uses all of the data that's available to most intelligently charge the batteries without impacting the availability that is needed. So now let's take a look at the live system. So here we have an example from one of our customers, and you can see that they have so far 41 chargers set up on Charge and Connect, and we can see right at a glance on the home page lots of information is available. So we know that there are 36 chargers available currently, and I'm able to click into here and see exactly which ones these are based on the naming standards, and the customer puts stickers on the devices as well. We can then see that there are 31 batteries connected, and again, I can take a look at that in more detail. More importantly, perhaps we can see the charger state. So we can see in this case, 6 of the batteries are perfectly ready to be used. They've fully charged, they've cooled down, and now they're ready. 3 have been charged but haven't yet fully cooled down. Now these still could be used, but it's not the preferred option. Really, to cool them down first would always increase the longevity of the battery. And then we can see that 22 of the devices are charging. We can see that the minimum power drawn in the last 24 hours was 21.3 kilowatts, and the maximum was just under 100. Now the nominal power is the largest amount that has so far been drawn at any one time, and we can see here that's just shy of 250 kilowatts. You can also see if there were any alerts, we'd have those at the bottom here. So if we click on the chargers button, we can see that same information listed down here, which batteries are cooled, which are available, and which are charging. If we go into utilization, this is where we can really get some great information. And you can see up at the top here, I can filter it down to whatever part of the infrastructure that I like. So I have the whole customer here. This is one of their locations, this is the second location, and then within each location they had 2 charging stations. But let's say for argument's sake, I want to see all of the data that's been available for the last 3 months. And we can see here they have a 96.8% of full charges, which is really great because it means that they're taking the best care of their batteries, and only 3.1% partial charges. If If we take a look at the depth of discharge, you can see that 89% are within that ideal discharge range, where they've used between 40 and 80% of the battery's capacity. Now, as we know that every time the battery is plugged into the charger, that counts as one cycle. By always discharging them to that correct amount, it means you're getting the greatest longevity out of the battery and maintaining the battery health. Now, moving down, if we take a look at the utilization of chargers, we can see that 60% of them were finished, only 0.1% were on delay, and we had about 13.6% where it was on standby. So you can see that the customer has a good utilization of chargers, which means they don't have too large of a charging infrastructure and it's not too small either. So if we move over to errors and warnings, we can see that within the last week, we've only had one warning. And if I click on that, we can take a look and see that the code is 30, which is thermal runaway. So that means that the charger would have stopped or slowed down to allow the battery to cool before continuing the charge. Now we can also see on here a utilization timeline. So we can see when every charger was either finished or in charging mode. And obviously this is quite a lot of information, but we can narrow it down to one specific day or one specific charger. Now you can see that this is quite a lot of information, so it may be more useful to just click into the one charger and take a look at the statistics. And we can see here in a little bit clearer, specifically for that charger, with the utilization timeline there. And if we move down to the load profile, you can see in the last 3 months since the installation was done, this is what our charging infrastructure has looked like. And you can see the real peaks and troughs. And this is where load balancing can really start to help smooth those out a little bit. So if we move down to the batteries, what you would see here if the customer had tag ID on the batteries themselves would be more specific data, but it is still possible for the customer to add batteries with all of the details that you can see here, and so that they can maintain their fleet. And we've already kind of touched on this, but we can see here, this is what the infrastructure looks like, where you have an overall customer or distributor or partner, and then from there you can have locations, which are the various sites, and then stations, which are the charging areas within there. And it's quite simple. You can see I can just add a new location or station. And this here is where I can also add PV Connect. So the penultimate feature we'll take a quick look at is the shift manager. So you can see here, what I'm able to do is create a shift, let's say starting from 8 until 7, Monday to Friday. And what that will now mean is that Charging Connect will know that between 8 and 7, Monday to Friday, that is when chargers need to be most available. And outside of that, it will then stretch and stagger the charges as much as possible to keep the current and overall kilowatt usage as low as possible. So the final thing we'll look at, and then we'll look at specifically PV Connect. The SolarWeb account that the customer has, they will just need to generate the key ID and key value, and from there they'll be able to connect it, and then we'll see what it looks like. So as this customer doesn't have PV Connect at the moment, we can take a look at another example here. And you'll be able to find it by going onto load profile, and once it's activated, it will be available. So you can see here that we've got, within this time period, we've got an overall PV coverage of 44.6%, where 2,300 kilowatts have been generated by the PV system and 2,800 have been taken from the grid. And you can see I'm able here to turn this information on and off. So if I just wanted to take a look at the AC power, I can see where the peaks and troughs are. And if I want to take a look at the PV production, obviously you can see it's spiking during the middle of the day. I'm also able to see the difference between the PV and the grid. And if I zoom in a little bit by clicking and dragging, I can go into specific detail on shorter amounts of time. And if I turn on this button here, AC power without load management control, you can see here that these slightly faded blue lines is where we would have been if load balancing wasn't enabled. So you can see here, for example, we had on a Wednesday night in February, 16.5 kilowatts was being drawn AC power. Without load management, that would have been basically double that amount. And even this was without us even producing any PV as it was during the night. And that's really the basics of PV Connect. You can see, again, the same information here, and I'm able to click and drag into any area and really see it in more detail. Now, combining this with SolarWeb, you can really get a great understanding of your overall energy consumption, how Fronius is helping you to reduce the energy usage of yourself or your customer, and you can also see your CO2 savings, which is a really great feature, particularly, as we've said previously, for operational and environmental impact managers. So thank you for watching and listening. And if you have any inquiries or questions regarding Perfect Charging or our digital solutions, you can get in touch with us on charger-sales-uk@fronius.com or on our main line at 01908 512 300. Thank you.
Okay, well, everyone, thank you very much for your time today, and we hope we can support you on some upcoming projects.
Great, thank you.
Goodbye.